All right, so, we're all about diving into the really complex stuff, and you guys sent us a great one. Nvidia's CEO Jensen Huang's keynote at GTC March 2025. Talk about a fire hose of information.
Yeah, it was, if you're into this world, it's exciting stuff to be sure. Lots about AI infrastructure and where it's all heading, but
Yeah.
yeah, a lot to process.
A lot to process. So
Yeah.
that's what we're here for, right? To break it down, make it digestible, and maybe even, a little fun along the way. So think of this as your express lane through all the NVIDIA news, the stuff that matters for the future of computing and AI.
Exactly. We'll cut through the noise and get to those core takeaways that you need to know about AI advancements,
Yeah.
data centers, accelerated computing, the whole landscape, really.
Perfect. So where do we even begin with this keynote? I think the heart of it all has got to be NVIDIA's new Blackwell generation of GPUs. I mean, what a journey from the early GeForce days to now with these powerhouses like the GeForce 5090 as part of this new Blackwell family.
It's pretty remarkable. And the performance gains with Blackwell, they're almost mind-boggling. The chips are physically smaller, they dissipate heat so much better, and the speed increases are just phenomenal. And what's really fascinating is how deeply integrated AI is becoming with the graphics side of things.
Yeah, I was blown away by that stat about the 5090, like 15 out of every 16 pixels in those ultra-realistic path-traced images are actually being figured out by AI. That's just crazy.
It speaks to a broader trend we're seeing. AI isn't just its own separate domain anymore. It's becoming this fundamental building block of how computing itself works.
Mhm.
And if we look at the evolution of AI, how it went from, basic perception to actually generating content in just the last few years, we're now stepping into this whole new realm of what's being called agentic AI.
Agentic AI. Okay, break that down for me.
Basically means AI that can reason things out, make plans, and even use tools to achieve its goals. It's a level of intelligence that goes way beyond just, recognizing a cat in a picture or generating a piece of text.
That's pretty wild. And
Yeah.
tied to that, you've got physical AI, which I know is huge for robotics.
Absolutely. Physical AI is all about giving machines a deep understanding of how the physical world works. Things like friction, inertia, object permanence. These are concepts that we take for granted, but for robots to truly interact with a real world, they need to have a grasp of these principles.
It's like teaching a robot common sense about the physical world.
Right.
Okay, so to make all this agentic AI and physical AI stuff a reality, there are obviously some pretty big hurdles to overcome.
You got it. The sheer amount of data that these advanced AI models need to be trained on, it's just astronomical.
Mm.
Then there's the challenge of figuring out how to train them without needing constant human intervention. And maybe the biggest one of all is the whole issue of scaling up computing power to handle all of this.
I think that's what really stood out to me in the keynote, this idea that the computing demands for all this advanced AI are way more intense than we initially thought.
Yeah, that's a key takeaway. The need for computation with agentic AI has gone up by like a factor of 100 easy compared to what we were dealing with even a few years ago. And it all comes down to this idea of tokens.
Tokens. Okay, I'm gonna need a little help with that one.
So think of tokens as the fundamental units of information that AI works with. They could be words in a sentence, data points in a data set, pixels in an image, whatever the AI is dealing with. It's breaking it down into these individual tokens. And the more complex the reasoning that the AI has to do, the more tokens it needs to process.
So like if you're asking an AI to plan out a whole trip with multiple destinations and figure out the most efficient route, that's going to involve way more tokens than just asking it, what's the weather like today?
Exactly. And with these advanced training methods like chain of thought reasoning, where the AI is basically thinking step by step, and reinforcement learning, where it's learning from trial and error, we're now talking about training models on trillions of tokens.
Trillions. Yeah, that's a whole different ballgame.
It is, and it's driving this massive expansion of AI infrastructure. The numbers Jensen shared about how many Hopper chips and now Blackwell chips they're shipping out to the big cloud providers, it's a clear sign that we're at a major inflection point.
So it's not just about building more data centers. It's about building different kinds of data centers.
Exactly. That trillion-dollar forecast for data center construction by 2030, it's not just about bigger buildings and more servers. We're seeing a fundamental shift from general-purpose computing to accelerated computing that's specifically designed for machine learning. And these data centers are evolving into something entirely new, what Nvidia is calling AI factories.
AI factories sounds kind of ominous.
It's a powerful image though, right? These facilities are basically designed to churn out those essential tokens at an unprecedented scale. And those tokens are then used to create all sorts of information and outputs.
So it's like the raw material for the AI revolution?
You could say that. And to power these factories, you need more than just the amazing Blackwell chips themselves. Accelerated computing is about the entire ecosystem, the software tools, the programming model, and crucially, those CUDX libraries.
When Jensen showed that slide with all the different CUDX libraries, it was pretty mind-blowing to see just how many there are and the sheer range of fields they cover.
It really shows how deeply NVIDIA is invested in this whole accelerated computing paradigm. You've got libraries like Numeric, which just makes NumPy, the most popular Python library out there, run way faster. That's a huge win for developers across so many domains.
Then there's Calitho, which is aimed at revolutionizing computational lithography, which is essential for manufacturing semiconductors. I mean, the fact that companies like TSMC and Samsung are backing it tells you how big a deal this is.
And for anyone who might not be following the semiconductor world closely, this is a huge deal because it directly impacts how quickly and affordably we can produce the advanced chips that power everything else.
It's like the foundation of the whole tech industry getting a major upgrade.
It's exactly. Then you've got libraries like Ariel, which is turning GPUs into 5G radios, paving the way for AI-powered wireless networks QOPT, which brings advanced mathematical optimization to industries, from supply chain management to logistics, and it's now open source, so even more people can benefit from it. And of course, there are libraries specifically focused on healthcare, with Parabricks for speeding up gene sequencing and MONAI for medical imaging. It's like a toolkit for solving some of humanity's biggest challenges.
And then you've got the work they're doing in quantum computing with Quantum and CUD Quantum and all the specialized tools for things like quantum chemistry, computer-aided engineering, data analysis with cuDF, and even Warp for doing physics simulations in Python. It really is this whole universe of tools that are making accelerated computing more and more pervasive.
And the foundation for all of this is the massive CUDA install base. It's practically everywhere, in cloud services, data centers, research labs. You've got 6 million CUDA developers worldwide now. That's a testament to the power and reach of this platform. And to think that Blackwell is 50,000 times faster than the very first CUDA GPU, it's mind-blowing.
Talk about the power of continuous innovation. So we've got this incredible power in the cloud, but it's clear that AI is moving beyond those massive data centers and into, the enterprise world, individual businesses.
Right. NVIDIA's full-stack approach, the tight integration of their chips, programming model, and software is crucial for that transition.
Yeah.
They've built this ecosystem that cloud providers love because it attracts a huge community of developers. But as AI makes its way into different businesses, we're seeing the need for more tailored solutions, different system configurations, operating environments, and specialized libraries that cater to specific industry needs.
There's a lot of buzz around edge AI, too, where the AI processing happens closer to the source of the data, like right there on the device.
Yeah, that was highlighted in the keynote with the partnership between Cisco, Nvidia, T-Mobile, and others to build this whole ecosystem for radio networks in the U.S. Right. That's a massive industry with billions of dollars being invested every year. And the potential for AI to transform communications through its ability to understand context and use prior knowledge is pretty remarkable.
And of course, we can't forget about NVIDIA's work in autonomous vehicles. I mean, they've been at it for over a decade now, and they've become a major force in that space. Their technology is being used by pretty much every self-driving car company out there.
That partnership with GM to build their future self-driving fleet, that was a huge announcement. It encompasses AI for manufacturing enterprise operations, design simulation, and of course the in-car systems themselves. It's a massive undertaking.
And their focus on safety with NVIDIA Halos, that's got to be reassuring for anyone who's still a little wary of self-driving cars.
Absolutely. Their whole approach, from the silicon design to the software, and the rigorous safety assessments they've done on millions of lines of code, plus their extensive patent portfolio, it all shows how seriously they're taking safety in this space.
All right, so let's get back to the data center itself in this new Blackwell architecture. One of the things that jumped out at me was this idea of scaling up before scaling out. Can you explain that a bit more?
Sure. So traditionally, when you wanted more computing power, you'd just add more servers to your data center. You'd scale out horizontally. But with Blackwell, NVIDIA is pushing this concept of scaling up first, meaning you pack as much processing power into a single system as possible.
So instead of having like 10 servers each with a moderate amount of power, you have one super powerful server.
Exactly. And that's where the design of Blackwell comes in. They're combining 2 GPUs into a single package, and you can have up to 8 of these packages in a single system. That's a ton of processing power in a relatively small footprint.
Plus, they're moving to liquid cooling, which allows them to cram even more power into a smaller space.
Right, exactly.
Yeah.
That's one of the key enablers for this extreme scale-up.
Yeah.
They're talking about the possibility of a 1 exaflops computer in a single rack. That's just insane.
1 exaflops. Okay, I know exa means a really big number, but can you put that into perspective?
It's essentially a billion calculations per second. To give you an idea, the fastest supercomputers in the world just a few years ago were in the petaflops range, which is 1,000 times less powerful.
Wow, so what's the point of all this concentrated power? What's the main workload that they're targeting with these super scaled up systems?
The ultimate goal is to tackle the most challenging computing problem in AI, which is inference.
Inference. Remind me what that is again.
It's the process of actually using a trained AI model to generate those tokens we talked about earlier. So once you've trained your model on a massive data set, inference is how you put it to work, generating outputs like text, images, predictions, you name it.
So it's the thinking part of AI after all the learning has been done.
You got it. And there's a fundamental tension between the speed of inference, which impacts user experience, and the overall throughput or efficiency of the AI factory, which affects cost and revenue.
Jensen used a great analogy about planning a wedding seating chart to illustrate that.
Yeah, that was a good one. If you want the AI to do a really good job figuring out where everyone should sit, considering all the complex relationships and preferences, it's going to take a lot of tokens and a lot of computation. But if you just need a quick and dirty solution, you can get away with using fewer tokens and less computing power.
So it's a trade-off between quality and speed, and managing the software side of these AI factories with all the GPUs working together and all the different types of parallelism, tensor pipeline expert. It sounds incredibly complex.
It is. And that's where Nvidia Dynamo comes in. They're calling it the operating system for the AI factory. It's designed to handle all that complexity behind the scenes so developers can focus on building their AI applications.
And they're working with Perplexity on this, which is interesting. They're known for their really powerful AI search engines, so it makes sense that they'd be involved in building the software for these AI factories.
Definitely. And the performance gains that they're seeing with Blackwell are just off the charts. With the new NVLink 8 and the even faster NVLink 72, plus the use of lower precision calculations like FP8 and FD4, they're seeing a 25x improvement in the number of tokens processed per second per megawatt of power consumed compared to Hopper.
25 times more efficient. That's huge, especially with energy consumption being such a concern in data centers.
It's a game changer.
Yeah.
And they've also figured out these max-Q operating points, which are basically the sweet spot between throughput and AI quality. You can adjust the settings to prioritize either speed or accuracy depending on your needs.
So you can dial in the performance that you need for a specific application.
Exactly. And for those really demanding reasoning tasks, they're seeing a 40x performance increase with Blackwell over Hopper. That translates into needing less hardware, fewer chips, and fewer racks to achieve the same level of performance.
That's a huge win for efficiency and cost effectiveness.
Definitely. And to manage and optimize these incredibly complex AI factories, they're using Omniverse to create digital twins of these facilities. It's like a virtual test bed where they can simulate everything before they build it in the real world.
So they can experiment with different layouts, cooling systems, power distribution, all in a virtual environment.
Exactly. And they're integrating data from all sorts of partners like British Schneider Electric Cadence.
Yeah.
So it's a really comprehensive approach to designing and optimizing these AI factories.
Okay, so what does the future hold? What's next on NVIDIA's roadmap?
Well, they've got a pretty clear plan laid out. Blackwell Ultra is coming in the second half of this year, followed by the Vera Rubin architecture next year, which will include a new CPU, GPU, and networking technology. And then in 2027, we'll see Rubin Ultra, which is going to push the boundaries of scale-up computing even further.
So it's like a yearly cadence of major upgrades, which is great for businesses trying to plan their AI infrastructure investments.
And there's one key terminology change to keep in mind. Going forward, each individual GPU die will be referred to as a GPU.
So what used to be called a multi-GPU system is now just a single GPU.
Exactly. And the leaps in processing power from Hopper to Blackwell to Rubin are just enormous.
They also talked a lot about networking with their InfiniBand and Spectrum-X technologies.
Right. They're really pushing the boundaries of high-performance networking, which is essential for these massive AI systems. Spectrum-X is all about bringing the qualities of InfiniBand to the more widely used Ethernet standard.
And then there's their new co-packaged optics technology.
Yeah, that was a big announcement. It's their first silicon photonic system that integrates optical components directly onto the chip. You can transfer data at 106 terabits per second using light.
So instead of using electrical signals to move data between chips, they're using light.
Exactly. And this technology offers huge advantages in terms of energy efficiency and cost compared to traditional pluggable transceivers.
So it's a key enabler for scaling AI infrastructure to millions of GPUs.
Absolutely. Okay, so let's shift gears a bit and talk about enterprise computing. How is all of this AI innovation impacting businesses?
It seems like the entire computing stack is being reinvented for AI.
That's a good way to put it. The way businesses access and utilize their data is changing. The focus is shifting towards semantics-based retrieval, where AI agents act as a digital workforce, understanding the meaning behind the data.
So instead of just searching for keywords, you're asking AI to find information based on its actual meaning.
Exactly. And they've got the new DGX Station and DGX Spark lineup, which are essentially AI-powered PCs for data scientists and researchers.
So you can have a super powerful AI workstation right there on your desk.
Exactly. And even storage is being reimagined for AI. They're talking about semantics-based storage systems that are constantly learning and evolving with built-in GPU acceleration.
It's like having an AI-powered brain for your data center.
And they've also introduced Nvidia NIMs, which is a collection of open-source enterprise-ready AI models that can run anywhere from DGX systems to OEM servers to the cloud.
So businesses can easily deploy these powerful AI models without having to build them from scratch.
Exactly. And they've already got tons of partners integrating NIMs into their platforms. So it's a really promising initiative.
Okay, so we've covered a lot of ground here. AI advancements, data centers, enterprise computing. Is there anything else we need to hit?
Oh yeah, robotics? How can we forget about robots?
All right, let's talk robots. This was another big theme in the keynote.
Absolutely. It's clear that the time for robots is now driven by labor shortages and the need for more automation. And NVIDIA's approach to robotics is all about physical AI, enabling robots to interact with the real world in a meaningful way.
And they're leveraging their entire ecosystem for this, from Omniverse to Cosmos to Isaac Lab to Mega.
Right. It's all about this continuous loop of simulation training, testing, and real-world deployment. They're using Omniverse and Cosmos to generate massive amounts of synthetic data, which is crucial for training robots. Isaac Lab helps refine robot control policies after initial training, and Mega allows for testing fleets of robots in these massive simulated environments.
And they announced Isaac GR00T N1, which is a foundational AI model for humanoid robots.
Yeah, that was a big one. It's built using a ton of synthetic data, and it features this really interesting fast and slow thinking system. It's designed to be adaptable to a wide range of robot designs and tasks.
So it's like a general-purpose brain for humanoid robots.
You could say that. And the challenges in robotics are very similar to those in other areas of AI, the need for data-effective model architectures and scalability.
But NVIDIA seems to be attacking those challenges head-on with their whole platform approach.
Absolutely. They've got Omniverse as the operating system for physical AI Cosmos, for generating AI models that understand the physical world, and a new physics engine called Newton that's specifically designed for robotics. It's a really comprehensive ecosystem.
So it sounds like we're on the cusp of a major robotics revolution.
I think so. The potential is enormous. And they've made GR00T N1 open source so anyone can use it and contribute to its development.
That's awesome. So to wrap this all up, we've explored the incredible performance leaps with Blackwell, the rise of these AI factories, the expanding world of accelerated computing and C2X libraries, NVIDIA's ambitious roadmap, and the transformative potential of AI in both enterprise and robotics. It's been quite a journey.
And one of the key takeaways from all this is the central role of inference as the defining workload for the future of AI.
All those tokens that we talked about, they're the lifeblood of the AI economy.
Exactly. So to our listeners out there, think about the broader implications of all this. What does the rise of these AI factories mean for your industry? How will increasingly intelligent AI agents change the way you work? And how might physical AI and robotics reshape your daily life?
We've covered a lot of ground, but hopefully this deep dive has given you some food for thought and maybe even sparked your interest in exploring some of these areas further. Maybe you'll dive into one of those C2AX libraries or start thinking about the ethical implications of these increasingly powerful AI systems. Whatever it is, we encourage you to keep learning and exploring.
Absolutely. The future of AI is full of possibilities, and we're excited to see what happens next.
Thanks for joining us on this deep dive. We'll see you next time.
See ya.